that just makes things worse whenever someone has to go get tested. And
I'm going to assume that's working. And oh, you can see there. Okay, yeah, can you see it? I spent a lot of time already like explaining all the processes. If I do the same thing and go over this review, we're gonna probably get to about halfway, right? Because I mean, it's just time consuming having to explain every step and why it's this, not that. What I'm gonna do, because again, spent all that time doing that, and there should be videos, and I have Zooms that I'm gonna upload, and you can always ask me outside of class, like email me or whatever, to answer problems for you. Today is literally, I wanna get all 10 problems done. I'm gonna pretend like I'm sitting there taking like this exam, and I'm gonna talk through things, but I'm not really gonna teach them per se, okay? So like if you're like, I have no idea where she got that from, put a little asterisk, put a question mark. After class, I'm hoping to have like, 10 minutes and be like, what are y'all's questions? Then we can go over it, okay? So don't freak out if I go fast or if I say things that you don't get, because I'll help you. This is exam 2 review. I've got a few more up here. I would assume everybody has one, but if you don't, you can get it. I've got my answers here. I've got the problems here. Okay, let's go. So for problem 1, it's f of x equals x squared plus 4x, and it's a negative 12. Since I'm recording it, I'm starting from the beginning, just because I don't know if I'm going to keep it on the other recording or if it's just not enough. Okay. Opens up or down. That's determined by my leading coefficient. My my a is greater than 0, which means up, which means it looks like this. If it opens up, that means that it has a minimum. And the minimum is going to occur at the vertex. Usually in the homework, it wants my x and my y, but she already told me all she wants is just the x value that it occurs at. So this has a minimum at x equal. So I actually need to figure out what my x point is. This isn't in standard form. This is in general form. So it's that formula that looks like the quadratic formula, but I only need half of it because I'm only solving for my x. My b is a positive 4. My a is a 1. So negative 4 divided by 2 is 2. Signs are different, so it's negative. So up minimum at x equals 2. Done with the first problem. Problem 2 is f of x equals, I have 2 open, x minus 3 close, square it, and then a negative 2. This problem is wanting to know up, down, vertex, axis of symmetry, XY intercepts, and graph. Okay, so opens up is going to be determined on my leading coefficient right there, my a, which is greater than 0, which means it opens up, which means my parabola, is going to look like this. My vertex, because this is in standard form, is great. All I have to do is just find my h and my k, and remember that my h is going to be the opposite value of what you see in your actual function. Because it's a negative 3, I get a positive 3. My k is just what I see, which is a negative 2. And then my axis of symmetry is going to be the value of my x, which I get from my vertex, which is just 3. And then my x-intercepts and my y-intercepts. Okay, so my x-intercepts occur when y equals 0, but we write it as f of x equals 0. That way I know that what I'm doing is setting my function equal to 0. For this one, because I don't just have factors, I actually am going to need to do some algebra and like FOIL that out. And it's mainly because of this negative 2 that's tacked onto the end. If it was just parentheses, I can do the shortcut, but I can't here. So 0 equals 2, foiling this would give me x squared, negative 3x is negative 6x. 3 times 3 is 9, signs are the same, so it's positive. And then a negative 2. So still just doing algebra, 2x squared, 6 times 2 is 12, signs are different, so it's negative. Don't forget your variable. 2 times 9 is 18, signs are the same, so it's positive. I noticed common terms at the end, so I need to combine them. And what I would get is 0 equals 2x squared, negative 12x. Signs are different. Subtract, keep the sign of the larger. And then still trying to figure out what the value of my x's are, because that's what I'm doing, is finding my x-intercepts. I noticed that that trinomial has a greatest common factor of 2, so I need to pull that out. What I get is, pulling out the 2, I'm doing division here. 2x squared divided by 2 is just x squared. 12 divided by 2 is 6. Signs are different, so it's negative. X divided by no x is just x. 16 divided by 2 is 8. Signs are the same, so it's positive. I don't really care that much about this 2. I could literally just solve this, but for continuity, I just want the trinomial on the right-hand side. I'm going to divide both sides by 2. 0 divided by 2 is just 0. If I divide this trinomial by 2, that's what would cancel as my 2's. So I get x squared negative 6x positive 8. I'm going to come right here even though I didn't want to. Okay, so I have 0 equals, if I factor that trinomial, I could either do quadratic formula, I could do the AC method, I could do whatever I want. I'm going to do trial and error. I know I need x's here. Factors of 8 are 1 and 8. 2 and 4 give me 6. A negative 2 and a negative 4 give me a negative 6. So that's what I want. Because I have factor set equal to 0, I would set each factor equal to 0, and what I would get is x equals 2 and x equals 4. Written in a ordered pair, I would get 2, 0, and 4, 0. Those are my x-intercepts right here. And then I'm going to find my y-intercepts. I'm actually going to try to find it right here. I'm going to move here. I'll just do this, even though I do have to graph this one too. So, okay, my y-intercepts. So my y-intercepts occur whenever x equals 0. The way we write that, though, is f of 0, because that's like f of x, but my x is 0. What this means is to plug in 0 wherever I have an x. You can use either way. I would like to do it with the original function we were given, because I can. It's easier, I think. So it'd be 2 times 0 minus 3 squared, and then a negative 2. F of 0 equals 2. That's a negative 3 squared minus 2. PEMDAS tells me to evaluate the negative 3 squared first, which would be a positive 9. 2 times 9 is 18 minus 2. Signs are different. Subtract, keep the sign of the larger. My f of 0, what I'm finding is my y. And so my y equals 16, written as a coordinated pair, would be 0, 16. So that is my y-intercept. And then I would graph using my vertex, my symmetry, and my intercepts. Now, if there is a graph on your exam that's just like a 10 by 10, just find a point and mark it, right? Because I didn't pre-solve these problems. I didn't really know where the y-intercept would be, okay? Looking at what I have here, I see that I need to cross at 2 and 4 on my x. 1, 2, 3, 4, 5. That's fine. Let's do my vertex. Goes down 2, 2, 3, 1, 2. There's my vertex. So that's my axis of symmetry because it's a problem. This tells me 2, 0. This one told me 4, 0. It crosses at, just make that 16, even if you have to kind of draw the line a little bit bigger. Y'all do whatever you have to do. If it only goes up to 10 and you need another number, instead of recording this, y'all can come down here, or if it's, you can't see. Very ugly, very pointy, but it doesn't matter. I don't care how pretty it is. I'm going to look specifically for x-intercepts, y-intercepts. Mark those clearly. That's really the main thing. I don't care if you're not an artist, because I'm not. Okay, so that was problem 2. Let's do problem 3. And I'll get this posted today, y'all, okay? Problem 3, we changed the problem, right? The problem that we have now is f of x equals, it's 2, open, x plus 3, close, square it, open, x minus 3, close. The problem wants in behavior, x, y intercepts, multiplicities, touch and turn, and like where does that occur, and the max turning points. Okay, so if you wanted to FOIL this out, you can FOIL this out, but I recommend not doing it because you don't have to. For the end behavior, put this into your calculator. Okay, you don't have to remember the greater than 0 and the odd and where it points. Put it in your calculator. So I'm lazy, y'all. End behavior. I entered it into my calculator. I learned that it fell to the left and it rose to the right. Okay, so now I'm going to do my x-intercepts. X-intercept is f of x equals 0. So that means set your function equal to 0. This is all factors. There's not a +5 on the end. There's not a -3. There's not a, any other operation. That's all multiplication. Huh? End behavior. That's all multiplication. Because it's all multiplication, all I have to do is set my factors equal to 0. This is a factor. This is a factor. Those are the only things that have to be set equal to 0 because that's all multiplication. Previous problem had a little -2 at the end. I had to figure that one out and like FOIL it and do everything I had to do. Here, all multiplication. So I'm actually just going to individually, how did I do that in there? I wrote it again. Okay, so this is me setting it equal to 0 because that's all multiplication. I'm just going to set each factor equal to 0. This exponent here is a 1 because I don't see anything there. Those are the multiplicities. Doing it this way and just setting those factors equal to 0, that gave me the multiplicities. Okay, so that's going to be x equals -3. That came from this factor, which had an exponent of 2, which means my multiplicity is 2 because it's even. I was told to do the direction that also had an even amount of things, right? Touch and turn. That's 2 things. 2 is even. So multiplicity of 2 tells me to touch and turn specifically at -3, 0. That is my x-intercept, the multiplicity of it, and what it's telling me to do. This one, I get what? X equals 3. I look at this exponent, that's the multiplicity. The multiplicity here is 1, which is odd. The direction cross, that's one direction. 1 is odd. So odd, what I do is cross, and more specifically, I cross at the point 3, 0. Okay, now I need to find my y-intercept. My y-intercept occurs when x equals 0. So we do f of 0. This means wherever you see an x, make it a 0. So f of 0, I get 2, open, 0 plus 3, close it and square it. Open, 0 minus 3, close, equals 2, open, that would be 3, square it. Open, that would be a -3. PEMDAS, evaluate the exponent first. I get 2, that's going to be times 9 and then times 3, equals left to right. PEMDAS still 2 times 9 is 18. And I'm going to do it times -3. Okay, so 10 times 3 is 30. 8 times 3 is 24. 30 plus 24 is 54, right? Signs are different, so it's negative. Y'all, this is my y. My little graph on the exam goes only to 10. So just pick some random little distance below it. I don't care if it's that close to it. It doesn't have to be far. Name it 54. Does that make sense? Like just the graphs that I put on there aren't huge if it was to be 54. Does that make sense? Okay. So this is saying y equals 54, right? But written as a coordinated point, 0, 54. So that is my end behavior, my multiplicities, what they do at their x-intercepts and the y-intercept. It asked me for the max turning points. Max turns. You do the degree minus 1. This is your degree, y'all. You add your exponents. 2 plus 1 is 3, right? 3 minus 1 equals 2. That's just saying the number of times your graph can turn is twice. It might not turn twice, but that's the max amount of times it can turn. So now that we have everything we need, we graph it. Okay, so I'm going to graph it. I'm looking at my x-intercepts. It's -3 and 3. 1, 2, 3, 4, 1, 2, 3, 4, just because I want some points out here, right? -3, 0 would be what right here? 3, 0 would be right here. End behavior told me fall left, rise right. This would be fall left, right? This would be rise right. I did the points first, so I know where to put my end behaviors. Okay, and then I know that at -54, that's where it's going to cross the y-axis. So looking here at -3, it said touch and turn. This is where the end behavior is. So it's going to go up to -3 and then it's going to come back down. because it's going to touch it and it's going to turn. It's going to cross at this y-intercept. And then at 3, it told me it's going to cross, which obviously it has to, because look, the end behavior is up here. It's got to connect to that end behavior, which means it does that, and you're done. Okay. Like I said, this will be on there, and then y'all, if you wanted to like leave and take pictures of these or something, you can, okay? Let's do 4. My goal is to mainly just get through this and then have y'all ask questions. For problem 4, we have f of x equals negative 2x cubed positive 6x negative 2. It wants our leading term, LC, that's the leading coefficient, right? And it wants our end behavior. I'm just literally not trying to write end behavior. It's the only acronym that would match with any other term we've done. So leading coefficient quite literally means the coefficient that's leading, that's in front, right? What do I get? I get a negative 2. For end behavior, use your calculator. Plug it into your calculator. Where did this come from? Plug it into your calculator. You're going to see on your calculator, so I'm saying y'all, you have to have your calculator to answer a lot of these problems. You're going to see that it's going to rise to the left, fall to the right. You could literally just draw me that right there. Rise to the left, fall to the right. You could write it in words as long as it matches what I have in my key. That's it for that problem. If it's 6, 7, 8 points, that's, you know, a lot of points to just be able to point out first number and enter something into your calculator. Okay, if not, you need to remember the actual thing, which was, I told y'all it looks like an X, and then that these points are going to touch, the other one's going to be opposite, and then this was a less than 0, this was a greater. Do you see what I'm saying? You have to remember all of that, or just have your calculator, right? There's no reason to have to do all of that. Y'all, even it confuses me sometimes. Problem 5. Problem 5 explicitly states to use long division. So that means you cannot just give me an answer, and that means you cannot use synthetic division. You have to use long division, okay? Not doing long division means no matter what work you put on the page, it's all wrong, okay? So long division, it told me to divide 12x squared plus x and a negative 4 by 3x negative 2. So what we're going to do is the division, the multiplication, subtraction, bring down. Division, multiplication, subtraction, bring down. It's the same process each time. So 12 divided by 3 is 4. X squared divided by x is just x. That's why it has to be lined up with this one. I get 4x. Now we multiply. 4 times 3 is 12. X times x is x squared. 4 times 2 is 8. Signs are different, so it's negative. X times no x is just x. Here we do the subtraction. I mean, it's still the same color. So here what we're going to do is subtract. And what I mean by that is those signs change. That was positive, now it's negative. That was negative, now it's positive. And I do that so this cancels, it went away, great, scoot over to here, plus 1 plus x, so positive 9. Bring down your next term, second verse, same as the first, divide. 9 divided by 3 is 3, x divided by x, they went away, it's no x, right? And because those are both positive, your quotient is positive. Now you multiply. 3 times 3 is 9. No x times x is, I said 9 and I wrote 3. No x times x is x. Now 3 times 2 is 6. Signs are different, so it's negative. And then here you subtract, which means to change their signs. Your 9x goes away, which is what we wanted, so that's great. 4 and 6 signs are different, so you subtract, keep the sign of the larger. That's your remainder. Your answer, it will tell you to write it in the form of quotient with your remainder over your divisor. So that would be your final answer. It's 4x plus 3 plus 2 over 3x minus 2. Okay, so on problem 6, I had y'all add the word possible, because at first it looks as if you're finding all the zeros, which is a very long drawn out process. Just listing the possible zeros, you're going to see how it's really not that. Credit Karma, go away. You're going to see how it's really not that long of a process, okay? So let's do problem 6. Problem 6, list all zeros, make sure you add the word possible. The problem itself will say use the possible rational, or use the rational zero theorem to list all the possibles. You know what I mean? It's real specific. So there shouldn't be any confusion on what you need to do. And the rational zero theorem just states that what you can do is take the constant and its factors and divide it by the leading coefficient and its factors, and all the different combinations that you get are all the different possible zeros, making sure to take positive and negative of both of them, right? So the function I have is f of x equals 4x to the 4th negative 3x squared plus 2. Can I say a note real quick, y'all? Here, if you're doing long division, make sure that all of your variables and all of the exponents like are represented. If it just goes from like the 4th exponent to no exponent or 1 exponent, we're missing an x cubed, right? We're missing an x squared. Do you see what I'm saying? And those are when you had to add the zeros. Okay, so make sure y'all remember that. Okay, so right here. My plus or minus p over q plus or minus factors. P, so basically you take your factors of your constant over your factors of your coefficient, your leading coefficient. My constant is 2, those factors are 1 and 2. My leading coefficient is a 4, and those factors, it's 1 and 4 and 2 and 2, right? But you just write the 2 once. So 1, 2, 4. So we're going to pair them. 1 divided by 1, 1 divided by 2, 1 divided by 4, right? 2 divided by, you do that whole process, however you do it. Personally, I think math people are lazy because that's just us. I'm not doing that. I'm going to put 1 plus or minus sign out in front of this parenthesis. And I'm just going to look and I'm going to divide these. 1 divided by 1 is 1, right? Now 1 divided by 2 is 1/2. 1 divided by 4 is a 4th. I'm done with my 1. Now I'm going to do my 2. 2 divided by 1, that gives me 2, right? Now if I do 2 divided by 2, I get 1. But I already have 1. I don't have to write 1 again. Then when I do 2 divided by 4, well, 2 divided by 4 is 1/2. I already have 1/2. I don't have to write it again. Those 4 right there are those 8, actually, because it's plus or minus. Those would be your answer. That work right there, and you're done. Another 6, 7, 8 point problem, right? So there's 2 in there that I don't believe take a ton of work, but you know, if anything, it should be free points. Okay, so, and y'all, if you wanted to, you could do plus or minus 1, comma plus or minus 1/2, comma plus or minus 1, all of them, right? It's just a whole bunch of plus or minus. All right, like y'all looking at me, why did she do that? Because I'm lazy. 7. Okay, now this problem actually says find all the zeros, right? I don't think a problem was chosen where it's like, you know, you have to keep doing it like the synthetic division over and over and over again. But your goal is that you understand what it means for something to have been a 0, right? This says find all zeros. And it's like 4, our function is f of x, 2x cubed, negative 3x squared, negative 11x, positive 6. It says given that negative 2 is a 0, right? This means that if I use synthetic division and I divide by negative 2, my remainder should be 0. Once I get a remainder that's 0, I can continue with that quotient and find all the other zeros, right? So instead of me having to find all the possibles and then plug stuff in, I'm already given one of them, right? Okay. So synthetic division, we pull down the coefficients of our function. I know it's like a little upside down house. It told me negative 2 is a 0. So that literally means I divide by that numerical value. It's already the 0, right? That came from what? That came from x plus 2, didn't it? Because negative 2 is a 0, this is a factor. They already set this equal to 0, and they already gave me the negative 2. So first step, bring down your 2. Now, synthetic division, we multiply, combine, multiply, combine, multiply, combine, right? I should get a 0 here. If I don't, something's wrong. 2 times 2 is 4. Signs are different, so it's negative. And then we combine. Both of those signs are the same. So what you do is you add them together and you keep their sign. And then we multiply. 2 times 7 is 14. Signs are the same, so it's positive. Right? Negative times a negative gives you a positive. And then we combine. 11 and 14, those signs are different. So you subtract, keep the sign of the larger. Put it in your calculator. 14 minus 11, you get a positive 3, right? Okay, and then we multiply. 2 times 3 is 6. Signs are different, so it's negative. Awesome. Additive inverses, they're the exact same number, but they have different signs, which means they cancel each other out, right? You have $6 in your bank, you spend $6, you have none dollars. But I needed the 0. This 0 means that, yes, -2 is a 0 because that's what I got for remainder, which is great because that tells me that this is one of the factors, right? So what you do is I'm going to go ahead and write the factor of this. And then because it did give me 0, that means I can use this quotient to find the other zeros. So because my original problem started with a degree of 3, when you write the quotient, the degree goes down by 1. So use these coefficients and pair them together with variables, and it's going to start with x squared. So we get 2x squared negative 7. So then the next one would be just x. And then I've got a positive 3. Well, it goes 2, 1, none, right? So that 3 is my constant. You just close it. You set it equal to 0 because that's what the problem said. Find zeros. This is how you find zeros, is setting it equal to 0, right? Now, looking at this, on the exam, there will be the 2 different ways to find the vertex, the standard and the general form. They won't tell you which one's which. You're supposed to know that if it looks like ax squared plus b plus c, that's that weird, like vertex quadratic looking thing, right? If it's that standard one, like problem 2, where it's a times x minus h all squared plus k, that one, that's when you just h and k. That's your vertex, right? There's also going to be the quadratic formula. Some people prefer that. So if you notice that you can use it, that's why I have that formula on there. Personally, I'm going to do the AC method. I've done it a million times. I feel like y'all should know it. So this is going to be a real short-handed version, okay? 2 times 3 would give me 6. Factors of 6 would be 1 and 6 and 2 and 3. A -1 and a -6 would give me a -7. So I'm going to go ahead and expand it using a -1 and a -6 because I know those give me this. And then here I can go ahead and pull my GCF. The only thing they have in common is an x. If I do that division, 2x squared divided by x would be 2x. X divided by x is 1. Signs are different, so it's negative. I have my negative there. They only have a 3 in common. I just know that my math is correct from just trusting it. And I do know that 6 is going to come from 3 times 2. So those need to match, and they do. And then these are going to be my 2 new factors. I have x plus 2, and then I just factored this one, okay? This 2x -1, because those match, that's one of my factors. What's left over, that's my other factor. Now I have factors equal to 0, set them all equal to 0. It started as cubed, so that told me when I end, I should have 3 factors, and I do, right? So now my answer for my x's, you can set them equal to 0, solve the little equations, right? I'm going to get -2, comma, a positive 1/2, and a 3. That make sense? Yeah, okay. Okay, we're on track to be able to ask questions, so that's really good. Okay, so we need to do 8, 9, and 10. 10, I feel like it's going to take probably the longest. Problem 8. Y'all, if a problem tells you to find the slope intercept, it's not saying see if one exists and making you really think that hard about it. It's telling you to find it, which means, okay, it must qualify for what it needs to for there to be one to exist. Does that make sense? Okay. So find the slant of f of x equals x squared negative x plus 1 over x minus 1. I know that I learned that a slant asymptote is going to exist if the degree in the numerator is larger by 1 than the degree in the denominator. That's a 2, that's a 1. Okay, it checks out, right? And the way you find the slant, we're looking for the equation of a line. That's going to be what gives us our slant asymptote. So the way I find this is to synthetically divide top by the bottom. That's a 1, a negative 1, and a 1. Okay, y'all, that is a factor. X minus 1 is a factor, right? If you do synthetic division, we don't divide here by x minus 1. That's when you set it equal to 0, right? I need to find the 0. I need to find what x equals right here. So x minus 1 equals 0 would be x equals 1, right? That's what I'm dividing by. I know it really is, right? And then bring down your 1 with all your other ones. You know, synthetic division, multiply, combine, multiply, combine. Y'all here? Okay, so what's it called? If you're actually going to find, I'm trying to think of how to say this. If you're doing synthetic division, I do care about my zeros. If it says find zeros, I do care about if this is a 0. When you do the slant asymptote, I don't care what this is. Okay, because these two numbers that I get right here, that's my M and my B. Okay, so let's go ahead and do it. 1 times 1 is 1. Signs are the same, so it's positive. Do our combination. Those signs are different, so you subtract. We would get 0. Keep the sign of the larger. Whether it's positive or negative, it really doesn't matter at 0. Okay, but I mean, here it would be positive. So y'all, this is my M. That's my B. I literally don't care what happens right here. Okay. Anytime, the majority of the time, you're going to have a slant asymptote. It's going to be a trinomial divided by a binomial. And so you're going to get the two things right here you need for M and B. Okay. So if we use this form and plug in this information, I get Y equals M is 1. So that's 1x, right? I'm just going to write X. My B is 0. If you write this, that is the correct answer. If you write this, that is also the correct answer. Not having an actual numerical value for your B just tells me that that 0 was the answer. Does that make sense? Like, because mathematically you can write it or take it off. It doesn't change anything. So either of those would be correct. Okay, y'all. Problem 9. Problem 9 is what we did in the last class, actually. Problem 10 is still 3.5. But I think I did it so you have enough room to solve everything. So problem 9, solve the inequality. The inequality they give me is x minus 5 and x plus 2 less than 0. I'm running out of lead or something. No? I just jacked my pencil up. Okay, so less than 0 means if something is less than 0, then it's negative. So that's what I'm looking for. When I start plugging in test points, I want the ones that come out negative. And because that is a strictly less than symbol, I'm not using brackets, I'm using parentheses. Now, step 1 was basically just to say that, you know, everything is with just a 0 on one side, it's already set up like that. You don't have to do anything. Step 2 was to actually take your function and set it equal to 0, or, you know, check your factors, set them equal to 0 so that you can solve for your boundary points. So that's actually taking both of them, setting it equal to 0, which just means you could set both of them equal to 0. My boundary points are going to be -2 and 5. That's where you divide into intervals. You can go ahead and, like, you know, declare those intervals, say what they are. Right here, we would have what? -infinity, comma -2. Right here, we got -2, 5. Right here, we got 5, comma infinity. Just a heads up on the exam, it looks like this. It wants your inequality with more words though, right? And it wants whether it's positive or negative. So this inequality would be listed, whether it satisfies your inequality or not. What were the inequalities that you found when you broke it up into your intervals, right? Then when we plug in the test points, you could write here positive, do a plus sign, write positive, I don't care. But this is a part of your answer on the exam, okay? So test points. I need a number that's inside of the intervals. I don't care what it is, as long as it's inside of the intervals. Right here, I would do -3. Right here, I would do 0. I'm just boxing them because it kind of helps me differentiate between the actual boundary point and the actual test point, okay? So now let me go ahead and start with -3. F of -3, plug into here, -3, -5, -3, +2. Signs are the same, add and keep, I get a -8. Signs are different, subtract and keep the sign of the larger, I get a -1. 8 times 1 is 8. Signs are the same, so it's positive. Does this satisfy my inequality? If this is positive and I'm looking for negative, that doesn't satisfy. And I can go and write right here. This test point came out of this interval and I got a positive. That does not satisfy, but I can go ahead and put positive right here. And, you know, wherever else you want. Does anyone remember the pattern? If this is positive, what is this interval? That one's negative. Put a negative here. So this one's what? Positive? Put a positive here. So there's only one that satisfies, right? So my solution set is only that right there. Parenthesis, -2, 5, parenthesis. That's my solution set. Honestly, not even kidding. Y'all don't need to plug in the other test points. Okay, you can maybe just to check yourself because it's like, I'm not really sure and I just want to make sure. You know what I mean? But if you do it, you'll see I wasn't lying to you. Solution set is the intervals which satisfied the inequality. This is the only one that did. So solution set is just -2, 5. Number line, there is one on the exam. Just find a -2, find a 5. You can draw a little point and just kind of do something like that. This is saying that, it doesn't like my hands. This is saying that my X can take on the values anywhere in between -2 and 5, and it'll make that inequality true. It can't equal -2, it can't equal 5, and it can't be outside of those boundaries, which is why these are called boundary points, right? And then that's actually drawing it on a number line. Like that's the graphing part of it. Okay, y'all. I'm gonna do number 10, and then we should have a handful of minutes. No one like comes into this classroom right after my next one, like all rude and stuff. So, so if y'all have questions, I could definitely say and answer them. Okay. Problem 10. Problem 10 says to sketch the rational function. This is another problem, honestly, which is like why you really need your calculator, okay? If you know the steps and you could do them, you could totally get it without a calculator, but like I would say have a calculator. My rational function is f of x equals 3x over x minus 1. He wants me to find the x and y intercepts and all of the asymptotes. Okay, so here because remember the rational functions are slightly different than all the other stuff that we did for the simple fact that it's written this way, right? Our x-intercept is found by setting our numerator equal to 0. So I would just get x equals 0, right? Because 0 divided by 3 is just 0. There's my x-intercept. Because we're going to graph it, y'all. Okay, that's saying that right at 0, that's where it crosses. That's where it intercepts the x-axis. My y-intercept is found by plugging in zeros for your x. Whatever you get, that's your y, right? So if I plug in zeros here and I plug in zeros here, well, 3 times 0 is 0. Honestly, you can stop there. It doesn't matter what you have in the denominator. 0 divided by anything will always be 0, right? So this is saying y equals 0. That's my y-intercept. Actually kind of like an easier example because it's just also at the origin. That's the only place it crosses y, and that's the only place it crosses x, right? So now we need to find the asymptotes. So y'all, I'm just I'm just lazy. VA, vertical asymptote. Okay, I'm trying to not write too much right now. Vertical asymptote. So we learned that the vertical asymptote was found by setting our bottom equal to 0, right? Our denominator equal to 0. So that's this, which would give me what? 1. What that means is at 1, we have a dotted, dashed, slashed, whatever line on your little graph. I go ahead and mark that because that would be something that would stand out to me. That's something I'm looking for, okay? On your calculator, it doesn't show you these lines. They're invisible. And then vertical asymptote, we need to see if there's a horizontal asymptote. So HA, VA, HA. Horizontal asymptotes was Bob, bought, eats, right? Is it bigger on the top? Is it bigger on the bottom? Or are the exponents all the same? So here, my exponent for my numerator, that's 1, right? The exponent for my denominator, that's 1. Exponents are the same. That told me to DC, which was to divide coefficients. 3 divided by 1 is just 3. When you find your horizontal, that's this line, right? That lays down, it's just horizontal. And so that's going through your y-axis, which means it's 3 equals y, or y equals 3, however you write it. So vertical asymptote gives me x equal. Horizontal gives me y equal. Okay, so this is saying that at 3, on my y-axis, I've got this invisible line. Draw it however you want to draw it, but draw it. So the fact that I had my calculator and I input this into my calculator, y'all can't see it in this class. It showed me that in the bottom left, it did this. And in the top right, it did this. Okay, that's usually enough information to kind of know what you're graphing. But what we need to do is actually plot some points, because if you look at what we have, the only thing we have is that it's going to cross at the origin, right? Just because y'all can't see my calculator. I'll go ahead and say it though. On the calculator, what I did was, after I graphed it and I saw what it did, I did second table, right? And I found points. With those points, that's what I graphed, okay? If you just don't remember how to do that, then we would literally just, there's gonna be a little thing like this on the exam. And I know that I need to plot points that are from right here, less than 1 over, because I need to see right here, what does the graph do? I know it just told me it does something like this. But if you just randomly draw something through the origin and I'm looking for points, like, that's not you getting all the points for the problem, right? And then up here, what point would you even use? If you're going to plot one extra one, you might as well plot a few extra ones, right? So I need something less than 1, and I need something greater than 1. Well, greater than 1, I'll go ahead and do 2 and 3. Less than 1, well, I'll do a -1. I learned whenever I did that I had a point here, but I didn't really have a point here. So what I did was I was like, okay, let me go ahead and do a half also. Okay, you can literally just compute it by hand, plug in half, -1, 2, and 3 into here, get your point. Okay, or just use your calculator. Have this entered into your y equals, and then do second table, find your x, and then it gives you your y, and then just go ahead and plot it. Okay. When I looked on my table for x equals -1, I got 1.5. So at x equals -1 on my y-axis, it was at 1.5, which I just kind of estimated it to be here. You having this shows me where you graphed it, and then I just see a point that should kind of correlate to it, okay? And then I have, when I did 0.5, that didn't show me on my table, but I wanted something in this area, so I actually plugged it into the function myself, okay? And what I got was a -3. So at 0.5, it went to -3, which would be about here. So now I know I can graph this side like that. I'm sorry, Colin, I cannot hear anything you're saying. And you pick it. I don't care if y'all chose to do 7 or 8 or 1.5. You know what I mean? It just has to be, it can't equal the asymptotes, of course, right? Because you'll get an error. Okay, so now let's do 2 and 3. I got 6 and 4.5. So at 2, let's call this 6. Let's call that 4.5. At 2, I got 6. At 3, I got 4.5. And I was able to just kind of roughly sketch it there. Again, I'm looking for points. Okay, points and the fact that you use this right here. If you did it by hand, of course, you get the answer. If you have your calculator, you don't even have to do the work. It gave you the answer. Okay, it's just a matter of did you plug your function in correctly into your y equals. Okay, so I'm going to turn this off. And then if anyone has any questions, we're going to go ahead and answer them. Okay.